Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic addition of bromine, Br2, to an alkene proceeds via an anti-addition mechanism through a bromonium ion intermediate. When isotopically labeled At2Br2 is used, both bromine atoms added are At2Br. However, the starting alkene here is a vinylidene type compound, methylene with substituents, where the double bond is exocyclic to the ring. Moving on to the next step. The starting material is 1-methylene exocyclic alkene on a cyclohexane ring with a substituent, propyl ethyl group on the exocyclic carbon. The double bond is between C1 of the ring and the exocyclic carbon is equal to CH. Moving on to the next step. At2Br2 approaches the double bond, and the more electrophilic At2Br forms a bridged bromonium ion across C1, ring carbon, and the exocyclic carbon. And for the final step, the bromide ion, At2Br, attacks the bromonium ion from the back, anti. Since C1 of the ring is more substituted, tertiary, part of the ring, the At2Br preferentially attacks C1 of the ring from the back face. The bromonium ion forms on one face, the nucleophilic At2Br attacks from the opposite face at C1 giving anti-addition. The exocyclic carbon gets one At2Br from bromonium and C1 gets At2Br from nucleophile, both labeled. The H on the exocyclic carbon remains. The major product has both bromines as At2Br, since At2Br2 is used exclusively. At the ring carbon C1, one At2Br added anti to the other At2Br on the exocyclic carbon. Option B shows Br82 on wedge at C1 Br on the exocyclic position, H on dash, and Br82 on dash, representing the anti-addition product where both added bromines are At2Br and the arrangement is anti-trans diaxyl-like addition. The non-labeled Br in option B on the exocyclic carbon actually represents the At2Br from the bromonium, and the arrangement in B correctly shows the anti-addition stereochemistry with both bromines being At2Br. Why other options fail? Option A shows a non-labeled Br at top and Br82 labels at bottom, incorrect isotope labeling pattern, suggesting SYN addition or wrong regiochemistry. Option C has a non-labeled Br at the bottom and Br82 at top, wrong isotope distribution. Option D missing the wedge Br, showing wrong stereochemical arrangement. Option B correctly represents anti-addition of At2Br2 with the bromonium mechanism, giving the trans anti-dibromide with correct isotope labeling. Therefore, the correct answer is B. Therefore, the correct answer is option B.